Mr. Beak's math class. Mr. Beak's math class. Yeah! Woo!
All right, everyone, welcome to math class for today. Today we're going to be talking about 2.1, 2, 3, and 4. It's a 2.1 through 4 review. These ones, that's an awesome E right there. These ones are going to be all just based on what we've talked about before we do the last section of 2.5. That one's kind of a little bit more unique, and so we're going to treat that one by itself, okay? So I'm gonna go through these quick. You can always pause the video and slow down if you need to. But first off, this says write an inequality to represent the situations. An inequality is less than or greater than, less than or equal to, greater than or equal to, right? And when we have to graph them, they have certain dots. So the less than or greater than is just a open dot, it's called, and the or equal to's is a closed dot, right? So an elevator can hold a maximum weight of 2,000 pounds. Let W represent the weight for the allowable weights that it can hold. So what I'm going to do is I'm always going to write my variable first, and I'm going to go over here and write the number next. And then I just know somewhere in here there's going to be one of those four signs, right? And so I just have to kind of correctly decide and decipher which one it's going to be. So let's just think about this in normal person words. If there was 2,500 pounds of people on that elevator, would it hold? Would it hold? The answer is no, because the maximum's 2,000. So it has to be less than 2,000, right? Could it hold 2,000? Yes. It could be 2,000 right on the dot, and somehow that elevator is holding, not with a little bit more, right? So let's not press our luck and test that, right? When we graph stuff, we put the important number right in the middle. We do one less and one more. 1999. And like I said up here, open or closed circles, this one's going to be a closed circle, and we want to have all the numbers that are less than that, okay? Real quick review, if we have our variable on the left, which is why I wrote it that way, if it's pointing that way, that's the way we shade. See how those are kind of the same arrow? Okay. Let's do another one here. Yeah, let's just do number 2 and we'll call it this section good. You have to get at least 60% of total points to pass this class. Okay? That's a true statement. We want you guys to get even more than 60% though. We want to get you to get as many points as possible. But if I have to write an inequality, we'll say P for passing. Like I said, I'm always going to write the variable on the left. I'm always going to write the important number that we want on the right. I'll write 60% on this one. You need to get at least 60%. Well, if I get 80%, would I pass the class? Yeah. If I got 90%, would I pass the class? Yes, right? So we want to get more than 60%. Okay? I think a lot of us can do pretty good at that. It's, do I include the or equal to or not? That's kind of the big question. Let me ask you a question. If you got 60%, would you pass? If the answer is yes, which it is in this case, then we would include it. So that's what it's going to look like. Oh, this one just says write an inequality. We don't even have to graph that one. Cool. We're going to call that one done. Let's move on to the next slide. All right, I want you to put a dot on the number that is x is less than or equal to 6. Put a dot somewhere on there. How about 1? Is 1 less than or equal to 6? Would that be a true statement? Yeah, that'd be a true statement, right? Is that the only answer, though? No. How about negative 8? Is negative 8 less than or equal to 6? That's also true, right? So what about all these in between, right? What about these ones that are in the center, right? There's going to be an infinite amount of dots that are in here, and so it's going to be all of those. Now, 6 is less than or equal to 6. But That's why we have a million bajillion answers. We have infinite amount of answers when we have these inequalities. So that's why we have to kind of specifically graph them as, hey, it's this one and all the ones that are to the left there. Let me fill that bubble in a little bit better. Okay, so real quick review on that. So let's just take a look at these. Write each sentence as an inequality. 3 is less than a number x plus 9. Well, let me just do that. 3 is less than a number x plus 9. That would be the answer to that. If we had to solve it, what would I do? I would just minus 9 to both sides, and I get negative 6. Right? If I had to graph it, this one's a little bit trickier because you have negative 6 and you have negative 5, negative 7. This one has an open circle, but notice that the x is on the right-hand side. I usually prefer it on the left-hand side, so then it follows the way of the arrow. So that means this one's going to go the opposite way of that arrow. This says negative 6 is less than x, or it says x is bigger than 6. Well, that would be that way. Okay? Let's do solve this inequality and then graph it. If I have to solve it, like I said, I like to draw that line. I like to write out my x, which is what I need to know. And I just want to get rid of everything by doing the inverse operation. So if I'm going to minus 5, it cancels there. We're left with 2x is bigger than 12. And then now I'm going to divide by 2, and I get x is bigger than 6. Perfect. Now, did I have to flip the sign in that one? No, I did not, because I just divided by a positive 2. So do one less and one more on each side. We have an open circle, and x is less than, or x is greater than 6. So it's on the right-hand side there, that variable, so it's going to go that same way. Oh man, that one looks kind of frightening. There's 2 negative signs right in a row. Well, if you remember, 2 negative signs right in a row, it changes into a big plus sign, right? So if you just rewrote it like that, that's the exact same thing as what we started it with. This just looks a little bit nicer and easier. So here I'm going to minus the 4 to both sides. 3x is less than, what is that, 18? Divided by the 3, and you get x is less than 6. I won't graph it for time purposes, all right? How about, let's do that. Let's do this one right here. That one looks a little frightening. I'll bring it to the top. Hide that stuff. All right. So, what do we always want to do first? We always need to distribute first. When I do that, I'm going to get 6x minus 3 less than. I didn't touch any of that 10x minus 11. So this is my new problem. Okay? I like to get all my x's to the left-hand side as a preference. You could get them all to the right-hand side too, that's fine. But I'm going to show to the left-hand side. So if I do that, it means I want to move this guy to that side, right? So how would I go about doing that? I'm going to minus the 10x. I'm going to do that to both sides, so I'm equal and fair. And now I have negative 4x minus 3 less than negative 11. Okay? Next step would be to plus 3 to both sides, and I get negative 4x is less than negative 8. My last step is I divide by negative 4 just like I would in an equation, and I'm going to get x, I'm going to get 2. But here's that tricky part. We got to remember, I divided by a negative number, so that sign was facing this way, now it's facing that way. Boom, there's my answer. Okay? Like I said, slow it down if you need to. I think I'm going to call that a review. Hopefully you guys feel a little bit comfortable on that. You guys take care.
Mr. Peak's math class. Mr. Peak's math class.